All right, so we agree that the distance between the two ends was 12.876. Is that right?
Yeah.
So let me make sure this is clear. This was 12.876. Is everybody agreeing with that? Anybody have any objections to that? So if that is 12.876, does everybody agree that's part of the circumference? Do we agree? So exactly what part of the circumference would that be? We would just take 12.876 and divide it by 15 pi. Because that's the total distance around. Does everybody agree with that? So what decimal is that? Somebody tell me what 12.876 divided by 15 pi. And I said you had to be real careful when you do the division. All right. How much?
2.6.
I got.
You didn't put it in parentheses. How much?
0.273.
So that's approximately what? 27.3% of the circle. Does everybody agree with that?
Yeah.
So all I have to do with that 0.273 is multiply by what? Multiply it by 360. Does that make any sense?
Yeah.
And what did that come out to be?
98.365.
98.365 roughly degrees. I'm okay with that. All right, I thought that was a really interesting problem. All right, now some of the ones at the end now are a little bit tricky too. Does anybody need any further assistance before I collect them and look at how you did?
You need number 34.
Okay, yeah, I actually think 34 is a good problem and I think it's important as well. So Sean has to buy a new wheel for her bike and the bike wheel has a diameter of 20 inches. If Sean rolls the wheel one complete rotation, how far will the wheel travel? I don't think that one's hard. How much? 20 pi, right? Because it will roll the circumference, right? That's what one revolution is. I want everybody to listen to what I'm saying. One revolution is one circumference. All right. So we would just say that that is going to be 20 pi inches. That's how far you will travel in one rotation. So if it rotates 45 degrees, 45 degrees is what part of the circle? 1/8. So it would just be 20 pi over 8 inches, which of course we would just say is what? 5 pi over 2 inches. Does that make sense? And then finally, if the bike wheel is rolled along the ground for 10 inches, through what angle? All right, now we know how to do that one. So it rolled how far? 10 out of how many? Out of 20 what? Out of 20 pi. And then all I have to do is, and then what? Yeah, multiply that by 360. Everybody do that now and tell me. All right, now again, I'm telling you, if you're not doing it on the calculator, you're going to make some mistakes. All right, make sure you know how to do it. And I want someone to tell me about how many degrees was that? 57.296 degrees. Does anybody else get that?
Yeah.
All right, so I thought those were really good questions. All right. Anything on these down here? I don't know if those were that difficult. All right, let's try 40. Who knows? Explain it. Tell me, Nate.
Is it just 1.5?
Well, but I can, hopefully you're correct, but I don't know what the answer is. I'm asking you, how do you do it? How do you figure that out? How did you know it was 1.5?
Well,
What is the answer?
I got B.
I got B.
I got C.
Oh, we probably.
I got C. What'd you get?
B.
B again?
C.
C again?
I got B.
B again? Come on, come on, come on, Ben, what do you think?
I got B.
Okay, now, come on, guys. I think this has nothing to do with the formula,
It's just.
and it has everything to do with what? Logic. Everything to do with logic. All right, now I think everybody should be able to look at that and say, obviously, this is the answer. All right. It should be obvious. So please tell me from S to T is how much? 3 pi. Is that all the way around the circle?
No.
No. So you should be able to tell me, obviously, all the way around the circle is how much? 18 pi. Everybody should be able to do that. All the way around the circle is 18 pi. How do I know that? 60 degrees is what? 1/6. Come on, guys. Everybody should be able to do that. I don't care about the formula. All right. The circumference of that circle had to be what? 18 pi. So the radius would obviously be what? 9. Right? Everybody okay with that now? Lexi, is that good?
Yeah.
All right. They're always going to give you a fractional part. All right. To me, it was easier just take the fractional part and convert it to a whole circumference. And then you could quickly figure out what the diameter or the radius was. What? All right, let's take a look at 35. So it says a model train runs on a circular track with a diameter of 4 meters. Which of the following is the best estimate for the distance the train travels that moves from the station to? So am I going? Which of the following is best estimate for the distance from the train travels as it moves from the station? I'm assuming this is the station to the grain, right? So how, what are you thinking, Maren?
I was gonna tell you where it wants to go, but yeah, we know which way it goes. Like if it's going from the station that way.
That's why I kind of hesitated, because it didn't say what direction, right? So I'm assuming it's just the shortest distance. All right. It doesn't say, right? Does everybody agree? So I'm just assuming it's there. All right. And if you thought it was the bigger distance, I don't think the bigger distance is even on there, is it?
Yeah.
It might be, but I don't know. Right. So Maren, what is that? How do I do that?
4 pi times 360.
That's what I got. What did you get? What did anybody else get? 4.4. Now, let's do me a favor, 4 pi, do that for me, 4 pi minus 4.4.
8.166.
Yeah, so that would be if I'm going the other direction, right? That would be if I went this direction. Do you agree? Is 4.4 closer to the answer?
Yeah.
Yeah, so that's why I think they went this direction. All right. That wasn't hard. All right, anybody else before I take a look? James.
39.
What is wrong with 39? The minute hand of a clock is 3 inches long. Which of the following is the best estimate for the distance the tip of the hand moves as the time changes from 12:30 to 12:45? So a lot of kids these days don't know the little hand and the big hand, right? because we don't use, everything is digital, right? But do we agree it's 15 minutes has gone by? So 15 minutes is what part of the hour? 1/4, right, James? So it's just 1/4 of what? The circumference. Do you agree with that? And it says the minute hand is 3 inches long, which means the circumference would be what? 6 pi. So then we just divide that by what? Divide that by 4. All right. Those are very good questions. Anybody else before I see your attempted work here? Okay, let's look at 37. Measure of angle LBM is 3x. And the measure of angle LBQ is 4x plus 61. What is the measure of angle PBQ? Well, PBQ is going to be the same as LBM, right? So it looks to me like this is 180 degrees, right? And we know that 4x plus 61 plus 3x has to equal 180. Do you agree with that? And so it looks like 7x plus 61 equals 180. So 7x has to equal 119, right? So x is equal to 17, right? And if x is 17, 3x would be 51 degrees, which is what that is. That makes sense now? Okay. All right. Let me pause for a moment and collect. Okay, so now we will talk about arcs and chords, specifically some of the relationships that are formed. So if we take points on a circle, then, for example, we call this chord RS. 2 endpoints that are on the circle is called a chord. And again, the largest chord is the diameter. The largest chord is the diameter. All right, and then we have this relationship. We would just say that is arc RS. So now, what do you think is true if I said that TV is congruent to RS? Yeah, the arcs are congruent. All right, the arcs are congruent. That's exactly correct. All right. And also, then the converse of that would be true, which just says if the arcs are equal, then what? The chords are equal, correct? All right. Now, something else, hopefully I'm not getting ahead of myself, but something else that is true, which I thought was obvious, was I'm going to make another circle, or try to make another circle. And I'm going to try to say that circle, those two circles are exactly the same. And I come over here and I say this. Let's say this is XY. And I say XY is congruent to RS. Then what's true about the arcs? Obviously, they're equal, right? It's not a big deal. All right, not a big revelation. So again, I always try to tell kids, to me, in geometry, if it looks true, what? It is true. All right, that's the way I like to think about it. All right, especially on these circles. I think that was somewhat obvious. All right. Now, again, this is kind of important. All right. So in a circle, if a diameter is perpendicular to the chord, then it bisects the chord. All right. Now, again, I thought it was interesting that you asked me about the proofs, right? It really wouldn't be hard to prove that. because we can draw from here to here and from here to here. Does everybody agree we can show that those triangles are congruent? Everybody agree with that? So these little things, I just don't think are that difficult. All right. So I always try to tell kids, I don't have it memorized. I try to think about it each time to see what's true. All right. So anytime if the diameter is perpendicular to the chord, then it bisects the chord and its arc. So in this case, this example, AW would be congruent to WB, and AX would be congruent to XB. And again, that wouldn't be hard to prove. In a circle, the perpendicular bisector of a chord is the diameter. And in a circle or in congruent circle, two chords are congruent if and only if they're equidistant from the center. All right, so let me give you an example of that. All right, so if I try to draw a circle and I try to establish the center and I draw this and I draw this over here, I'm trying to make it the same. And that's how I do with all these. If I'm having trouble remembering, I just draw them out. Now, the hard part people don't know sometimes is, how do I know what the distance is to this chord? What is the distance to that chord? Can anybody tell me? Not like numerically, but how do I know that's about the distance? Yeah, because it's perpendicular. All right, the shortest distance from a point to a line is the distance between the point and the line. And the shortest distance would be if you traveled what? Perpendicular. All right, so the same thing over here, right? If you come out and say that this is equal to this, then obviously what? Yeah, the chords are equal. The chords are equal. All right, so to me, like I said, it looks true. All right, so keep that in mind. All right, there's lots of rules we're going to be talking about. And it seems like there is a lot to remember. But again, I think it can all be drawn almost, and you can try to write out the rules based on observation. All right, so with that in mind, all right, let's go ahead and review. All right, so again, let's try to get as much as we can done. The more we do, the less we have. So with that being said, I need to figure out this right here. Someone tell me the measure of that arc. Go ahead, don't be shy.
148.
Of course. Why is it 148, Ben?
60 minus 64.
Yes, exactly. Exactly. Now, that's a perfectly good way of doing it. But I could also say, if I drew that down, I looked at it as this is 32 degrees here. And then the rest of that is 180. Does everybody agree? Or it doesn't matter. Whether that's true. All right, so now what's the angle measure for that? Somebody want to tell me? How much? Someone, come on, this is on number 2. It should be easy. Why do you think 122? I'm not saying you're wrong. I'm just asking. I want people to tell me.
I just did like what we did for the last question, but that doesn't make sense actually.
Yeah. Again, I that's what I want you to do. I want you to try to think about it. All right. I think it's what? What do you think it is?
I know it has to equal 360.
Come on.
242.
Tell me, Maren. Just come on. It might, yeah, of course it's 116. Why is it 116? Because this arc, I'm sorry, this chord is equal to this chord. Therefore, the arc is what? 116 degrees. Remember what I told you? Because it's a central angle, that's also the measure of the arc. Right, is everybody with me on that? All right. Does everybody agree that is a central angle? That's a central angle. All right, does it matter how big your angle is? Does that affect the degree measure? No, right? Come on, look up just so I can show you one thing. If I draw this and I draw this, the measure of the angle that is created is still what? 116, right? If I make the angle really super tiny, that angle is still what? Yeah, 116. It doesn't matter how big it is, the angle stays the same. All right, hopefully that's helpful. All right, so question 2 is 116. Okay, so now, that was number. All right, let's look over here. Yeah, now I'm not real happy with this because I guess when I copied this, it didn't do it. It really should be this, though. I think that's kind of a mistake. Put that in there. Make sure you put that in there. It's got to be perpendicular in order for that to be true. All right. So they kind of messed up on that example. But it has, you have to see that it's perpendicular. If it's not perpendicular, we don't know that that's the distance from the center to the chord. All right, but I'm assuming that's true. They meant to write that in. So this is 82 degrees. Yeah, so is everybody happy with that? 135, a little repetitive here. And then everybody just say X equals 7. Should be no work. All right, and over here again,
X equals 2.
yeah, X equals 2. I knew that wasn't going to be that hard. All right, now hold up. Let me see something. All right, let's take a look at number 10 for a quick second. Let me see if this is. The radius is 13. Go to number 10, 11, 12. Let's do this. The radius is 13. RS is 24. So I would like you to tell me what is, somebody tell me what TS is.
12.
12. And RT is what?
12.
12. Someone to help me with PT.
1.
Very nice. Very smart. Why is TP 5? Somebody else besides Olivia. How does she know it was 5?
Oh, 12, 13, 5.
5, 12, 13. But where is the right triangle? What? Well, this is a right angle. I'm agreeing with you. I don't see a right triangle that relates 5, 12, and 13. Say it again. Yeah, listen, the hardest part on the standardized test is when you have to draw something. All right, that's the hardest thing to do. All right, and some people just visualize things. I'm not one of those. All right, I'm looking at this staring going, I don't know how to figure that out. All right, then all of a sudden, you know the radius was important, but does QP help me in the picture?
No.
No. Does this help me? How does that help me? But I still have two unknowns. What do I need to draw, Olivia? That one doesn't help. So how do I draw the diameter? I mean, drawing a diameter. So now how does that help? Come on, guys. Say it again. Yes, from R to P. All right, from R to P is the critical part. All right, draw that in, please. Now, what is RP, guys?
The radius,
The radius. So it's what?
13.
13. That's why this is hard sometimes. A lot of times on the test, people cannot draw in the right figure to help them solve the problem. All right, I don't mind Maren saying draw a diameter. All right, so draw a diameter and see if it helps. I tried to draw QR. Does QR help me? No, it doesn't help me because it's not a radius. So we want to draw PR, which is 13. All right, is everybody good now? And so now we see the 5, 12, 13. So I know PT is 5. And then what, somebody tell me what is TQ? Yes, TQ is now 8. And now if I wanted to find QR, could I find QR? Yes. All right, we can. All right, so I thought that was a very good problem. What did we say RT was? 12. All right. Let's look at, I don't think that's hard either. Let's look at 17. So because CD is congruent to CB, then what is true? Arcs are congruent, so you can mark that. Is congruent to that. What else is true?
GQ and QB is under.
That is exactly correct. All right. These two things are equal. So if that's the case, what do we have here?
3x on 6 equals x plus 5.
I like it. So X would just be what?
11 over 2.
That's what I like. 11 over 2. All right, that was kind of easy. All right, let's find something else that might be challenging. Okay, let's do 32. Let's do the ones at the end. Those are always a little bit trickier. So I want to help you with those. So let's take a look at 32. All right, so try to do that. I'm going to pause. I want everybody to take a minute. Okay, someone tell me why I thought, or I think it's 4.8 without doing much of the work. And then I'll show you if I'm right or not. There you go. But why is it 2.4 times 2? But how did I get 2.4 though? But how can I do it without doing Pythagorean theorem? Okay, so remember earlier in the last chapter, I said, if you know these, it will save you a bunch of time on standardized tests. I said, if you remember 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Right, does everybody see that? Right, I'm going to show you, I'm definitely going to show you, but does everybody see what I'm thinking? I immediately knew we were dealing with right angles and right triangles. So as soon as I saw 7 and 25, I knew that it had to be what? 2.4. And then in my mind, I visualized, okay, that's one part of the chord. So the other part of the chord has to be the same. So it's 4.8, right? But let's say that didn't make any sense. All right, that doesn't have to make sense. That's something I would want you to know, just like when you're taking standardized tests, it can really help you if you know those triples a lot, just like right now. But I also am trying to expect you guys to draw yourself a circle, right? And just see what goes on. All right, so it says that you have a chord. So I'm going to draw a chord and I'm going to put in a center and I'm going to say from here, the distance is 0.7, right? And the radius is what? So I draw this in here. I just don't know why someone is sitting there saying, I have no idea. That's the problem I have. All right, everyone should have an idea because everybody can draw. All right. And then you put in that right angle. And you say it's just Pythagorean theorem. So this came out to be 2.4. So this is 2.4. So the answer was what? 4.8. Come on, guys. All right. You can do that. 4.8. All right. Let me see if there's anything else tricky. All right. Let's just try 38 because it's the last one. And usually the last ones are a little bit tricky. So let's see. So 38 says in circle C, the diameter is 22 centimeters. So in my mind, when I do 22 centimeters, do I write 22 centimeters? No, because I can't really physically do it without messing something up. So I do right like this. I put an 11 there. Now it says MN is 18. So if MN is 18, I don't have anywhere to put MN. So I squeeze in what? I squeeze in 9 here and 9 here. And now I'm trying to find CP. So if I'm trying to find CP, now everybody should be able to do this time. Everybody should be doing it quickly, quickly, quickly. Is it B? Now, what do we have to do though? I mean, you don't have to do it now that you know, but I would like for you to draw what?
Right triangle.
Yeah, but what triangle? What right triangle am I talking about? Yeah, so you need to draw that. That's what I'm trying to teach you. A lot of times when you take standardized tests, they leave out parts that you need to draw in. And sometimes you're going to draw something and it doesn't work. So draw something else. All right, so now we know that CM is what? 11. All right, so now I know that CP is just the square root of what?
11 squared minus 9.
That's what you should be saying. All right. And that's just the square root of what? 40. And because we are brilliant, we would just say that's 2 radical 10. All right. Now, if we don't have a calculator, how do we know what it is? How do we know which one the answer is? Tell me. Come on, everybody should be able to say, okay, square root of 40 is about this.
Well, you can just like say that the square root of 10 is around
Yeah. Square root of 10 is a little bit more than what? But listen to me. This is something I think is critical. 40 is between what two perfect squares? Right, but I'm asking you, what is 40? 40 is between what two perfect squares? Yes, you're going to say it's between 36 and 49. So it has to be what? Between 6 and what? Has to be between 6 and 7. Is it closer to 6 or closer to 7? It's closer to 6 because this distance is 4 and this distance is what? 9. All right. So you should be able to say just mathematically, it's 4/13 of the way, which is true. All right. If you did 4 divided by 13, that's pretty close to 6.3. I mean, 4 divided by 13 is close to 0.3. All right. So with that, guys, I think today was a great day again. I appreciate it. So I hopefully you're just going through those, just saying this is really easy, just a bunch of rules. Tomorrow I'm going to give you a bunch more rules. All right. So make sure it's done, guys. Make sure it's done. I appreciate it.